Hi everyone, today I'm going to teach you how to do topology optimization in Solidworks. The first thing you want to do is go to Solidworks add-ins and make sure simulation is turned on. Then you can go to simulation and do new study and make sure it's set to topology study. In this example, I'm doing the topology study of a table, and the first thing you need to do is go over here and apply your favorite material. So I'm just going to pick nylon 101 and hit apply, hit close. I'm going to skip over the connections button and go to fixtures, and I'm going to add some fixed geometry, so just places where the table will be fixed. And I'm going to pick these underlegs right here, I guess where the table would sit. And I'm going to hit the green check mark. Next, I'm going to pick my external load or my loads. I'll just do a force meant to represent stuff sitting on the table. And so I'll pick a force on this top face of about 2,000 newtons, and I'll hit the check mark. You could also pick a pressure or a torque or gravity, depending on what your table will need. Next, we're going to pick the goals and constraints for our table. You usually want to pick best stiffness to weight ratio. The other ones work as well, but this is just the default option. And here we're going to pick a mass constraint and choose to try and reduce the mass of this table by 30%. You can also specify different constraints like displacement or frequency or factor of safety. For this demonstration, we'll just be doing the mass and trying to reduce it, as well as the green check mark. Then for manufacturing controls, we'll hit add a preserved region. What this will do is this will basically have a region that the mesh will not touch and that the topology optimization will not touch. So they will not be solved by the solver. For this example, I'm just going to choose the underside of these legs and just kind of see what happens. So hit the green check mark. Then you want to go over here to mesh and you want to hit create mesh. And you can set your mesh density. I'm just going to hit this reset button so it goes to the parameters that will make the weight calculated be the amount we want taken off. And I'm going to hit the green check mark, and it's going to calculate the mesh. Once it's done, we should see the mesh on our table, and then we can go over here to the top and hit run study. This will take quite a while, so just be prepared. You'll see it running the iterations here on this little pop-up screen, and you can view the frequency and convergence process in the dialog box as well as in a graph. If you hit the graph button and you go show graph over here, and you can see that it's starting to go towards and converge to its best stiffness ratio and the mass target that we want as well. And so then we'll just let it keep going until it finishes running the study. So after it's done, you're going to get this gradient plot that tells you the material mass you need to keep and the material mass you're okay with getting rid of. If we go over to material mass, we can right click and hit edit definition. And we can decide how much material mass we want to get rid of based on this arrow, and our gradient will change as a result. So we'll see that we need to keep all this material mass if we slide it over to the right. And then we can calculate the smooth mesh here. And it will show us what our new topology optimization table looks like. You can see it's pretty symmetrical. And I'll just hit the green check mark over here. And I'll right click on this again and hit export smooth mesh. I can save it as a part file into a new part as a graphics body or a solid body. If it's a solid body, I can edit off of it. If it's a graphics body, I can save it as an STL. So I'll save it as a graphics body for now. Then I'll also save it as a solid body just to show that you can edit off of it. So one, export smooth mesh, advanced export, solid body, green check mark. Here's the table saved as a graphic body. You can see if I try and sketch on it, I can only sketch on the planes and I can't select the top of the table to sketch on it. And here's the top of my table as a solid part. You can see that it has all of the little mesh generation triangles here. And I can select one of these faces and start sketching on it. And I can now use this as a normal part in Solidworks. The graphic face will look like this because that's just how the mesh came out. But I can now make my table however I want it. So I can add a block on top of it and call it a marble countertop. Marble countertop, like that. You'll notice that it's imported as one solid body over here, but each of the individual meshes is recognizable by itself. Similarly, if I go into my 3D print software slicer, I can add the table like this, and now I can use an additive manufacturing process to print this table with the topology optimization study run on it. And that is a very brief introduction on how to do a topology optimization study in SolidWorks. You can definitely play around with the settings and with the math to get better and more accurate results. But this is just an introduction on the steps and how to do it. Thank you for watching. Oh, one quick final note. When you run a topology optimization study in SolidWorks or any mesh for that matter, typically it will generate a bunch of different folders and files that can be saved to a directory. These are files like the performance log, an automatic STL file, and these files with different endings. I'm not entirely sure what they do, but this is completely normal.